Hi, my name is Jiaxin Wang, and now I'm going to demonstrate my code structure and code detail for my project, which is the um, auction, an auction application running on Ethereum blockchain. So my code structure is not very complicated. The challenging part is to use the Ethereum blockchain. So I have to set up the Ethereum blockchain network infrastructure. And also, I need to learn a new programming language, which is Solidity. For now, all the Ethereum blockchain smart contract need to be written in Solidity programming language. Um, and my application is running as web application. So the user basically the user visit our application from the web browser. So it needs to have a web application backend, and I choose to use Node.js. This is because for now, for the community on Ethereum blockchain smart contract, most people use the Node.js, and the JavaScript works with the Ethereum smart contracts best. So that's why I choose to use JavaScript to implement my my backend side of my web application. But actually, all the application, the business logic, run on the user's web browser. The backend just um, provides the access to the web browser, and all the operations, all the actions done by our users, and all the transaction calls is sent directly from the user's browser, and they won't need to send anything like their accounts, their Ethereum accounts, their wallet info back to our server, which makes the user and which keeps the user's privacy on their end. We don't need those information, and this thus makes our application more secure. And it's the user's responsibility to keep their web browser or their running environment safe to run our application. Okay, and now this you can see that here there's a contract folder. This contracts folder basically will put all our smart contract definition in this folder. And you can see, since this is auction application, definitely we have auction smart contract here. You can see it's the file name is .sol, S-O-L, which means this is a Solidity file. Okay, you can also see the Solidity version 0.7.4 here. But you can think the smart contract very likely an object-oriented programming class. You see, for auction, it has these attributes here, like the item, which is, you can think of auction as title, or the item's name of the auction, and the item description, the start price, the owner, which is the creator, the publisher, the owner of this auction, and also it has the current highest bidding and the current highest buyer. Okay, you can see the address and the owner and the current highest buyer. There are the variable type is of address. This is a specific type in Ethereum blockchain which can bind to an Ethereum account. So basically, user use their accounts need to associate their account with our application, and everything they do, they post to the Ethereum blockchain, it's linked to their accounts. Okay, also it has the last update timestamp, and the Boolean value indicates whether this auction has been ended or not. And yeah, just as I said before, it's very likely to an object-oriented programming language. So it has, besides the attributes here, it has a constructor, and it also has methods, though it's defined in function here. And also for the Solidity programming language, it has some modifier which adds some more requirement to a function. Say the restricted modifier requires that only the owner can do such an operation. And you can see for the end function, which means to end this auction, it can only be done by request by the owner, so it has the restricted modifier here. And also the open auction modifier requires the auction still open, and you can see the bid. If you want to bid for the auction, of course the auction needs to be still open, it's not ended. So that's quite much. That's not very complicated for the Solidity program language. And besides the auction smart contract, we also have a auction factory smart contract here. Basically, it manages all the auctions posted from our web application. The auction smart contract can be an individual smart contract, and yeah, I mean anyone can call this auction smart contract constructor to post an auction to the Ethereum blockchain. But if this auction is not posted from the auction factory's method, which is here, create auction, then it's not managed, it's not recorded in the auction factory smart contracts, so it cannot be viewed from our web application. So this adds some security to our web application, that only the auctions created from our web application can be viewed from our web application. Basically, you can see on the right side of the screen, you can see this is the front or the index page of our web application, and for now it shows the created or the posted auctions here, and this is the you can see here all the information is basically provided by the auction factory's get auction summaries function. And for this is a detail page for an auction, so you can see all the data required to render this page is basically from the auctions here get summary function here. Okay, so that's all of our smart contract definition here. And the migrations.so is I use Truffle to deploy my application to the Ethereum blockchain. So this is built-in by created by Truffle. We can just ignore this part. And basically, the Solidity, the file smart contract definition, it will be compiled into a JSON file to make it serializable. That's how it can be posted to the Ethereum blockchain. When you post something through the network, it needs to be serializable, right? So the Solidity program language is going to be compiled into the JSON file, but it's very complicated. It's compiled files. I'm not going to expand that. I'm just going to show that once it's been compiled, it's a JSON file. And others, that is the JS file. That is the file we define the business logic running in the user's web browser. So like there are auction.js factories, they just mapping the auction smart contract and the auction factory smart contract to provide the instance or provide the function to retrieve the instance of the certain auction, the instance posted to the Ethereum blockchain or the smart contract auction factory instance of our web application. And also have some routes definition for define the pages routes of our application, Web3 JS, which injects the Ethereum blockchain infrastructure into our application so that our web application can connect to the Ethereum blockchain. And also this pages file, these are the file for our front end the page. We use Next.js, which is upgrade version of React.js running on the front end as our web application development framework. So you can see, though they are JS files, they render some HTML to be shown on our web browser. So that's quite much of it. And one more thing I'm going to explain is that test. So we also write some unit test for our smart contract, and it's placed under this test file. Basically, we do all the unit tests for each function in the smart contract definition and make sure that our application is running as we expected. That's quite much of it, and you can view this code and compare to my previous video on the demo of my project to have a more clear view of how I implement this project. And I also post all this code to GitHub later, and that's quite much of it. Thank you.